So in this last lesson of Unit 3, we are going to be talking about factoring the differences of two squares and factoring perfect square binomials. So a difference of squares is a pattern that you will see quite often. And there is a way around once we get to solving that you can use to actually get your answers rather than factoring it all the way out. But there are times where this pattern does come in handy. So whenever you have a difference of squares, you actually will have two terms because it is a binomial where both terms are perfect squares. Okay? And one term is subtracted from the other term. So we have a pattern that this follows for factoring. So if you have a squared minus b squared, which is your difference of squares, then that is going to factor into a plus b and a minus b. So a is going to equal the square root of a squared, obviously, and b is going to equal the square root of b squared. So in this first example here, we have x squared minus 100. So this is a squared and 100 is b squared. So to get a, we are going to take the square root of x squared, and that is going to be x. Then for b, we're going to have the square root of 100, and that is 10. So we're going to take our pattern, and we will have a plus b as x plus 10, and then we will have a minus b as x minus 10. Then for number 2, we have our first term as 4x squared and our second term as b squared. So for a, we are going to have the square root of 4x squared, and that equals 2x. And then for b, we're going to have the square root of 25, which is 5. So we are going to put this in our pattern, and we will have 2x plus 5 and then 2x minus 5. All right, so rather than you try both of these on your own, I'm going to go ahead and do this third one with you, and then you're going to try the next one on your own. Because this first one actually has a GCF in it, and then you're going to have a difference of squares once you factor that out. So if we take 108 and divide it by 3, we actually get 36. So our GCF is 3. So we're going to have 36 minus x squared. And 36 and x squared are a perfect square. So for our a term, we're going to have the square root of 36, and which is 6. And then for our b term, we'll have the square root of x squared, which is x. So then we will have that 3, and then in parentheses, we will have 6 plus x, and then 6 minus x. Make sure that you do keep your a and b in order. So now I want you to go ahead and pause the video and try this next problem on your own. When you are done, hit play to see how you did. All right, so you should have a GCF of x that needs to come out. And you should have noticed that because you have these weird powers of x cubed and x to the first that are not perfect squares. But if you take out that x, you get 81x squared minus 1, and that is a difference of squares. So for a, you should take the square root of 81x squared, which gives you 9x. And then for b, that gets you the square root of 1, which is 1. So we have x and then 9x plus 1, and then 9x minus 1. All right, so now for our second pattern. That is the perfect square trinomial. So for a perfect square trinomial, what you will see is that you have a perfect square as your first term and as your last term. And then in the middle, you are going to have twice the product of the two square roots. So most of the time you're looking for those perfect squares on each end. So what's going to happen is that when you factor this, it's going to factor into two identical factors. So you will actually take those and list them as one, but it is squared. So in this first problem, I see that we've got n squared minus 6n plus 9. So n squared is a perfect square, and so is 9. So if I take the square root of n and the square root of 9, I can factor, so I have, let's see, for a, I'm going to have the square root of n squared, and that's going to be n. And then for b, I'm going to have the square root of 9, and that's going to be 3. So I have n and 3. And then I'm going to take the sign of my b term, which is negative, and it's going to be squared. Now, if I try to factor this the way that we learned in lesson 5, it is still going to work because two numbers that multiply to be positive 9 and add up to be negative 6 are going to be negative 3 and negative 3. So for our next problem, we are going to go ahead and take a GCF first because I don't see any perfect squares, but I do see that every single number is divisible by 5. So I'm going to have that 5 divided out. That will leave me with n squared plus 10n plus 25. And that will leave us with a perfect square of n squared and a perfect square of 25. So the square root of n squared is n, and then the square root of b squared is 25, so that gives us a 5. So we are going to have 5 times, let's see, n and 5, and since our 10 is positive, we are going to have n plus 5, and that is going to be squared. So now I want you to go ahead and pause the video and try these two on your own. And when you're done, hit play to check your answers. So for this first problem, we have a is going to be the square root of 16x squared, which is 4x. And then b is the square root of 9, which is 3. So we are going to have 4x minus 3 squared. Then on this next problem, we actually don't have a perfect square right now, but we can slide and divide. And so that's going to give us x squared minus 60x plus 900. And 900 is a perfect square. So we can actually factor using that perfect square trinomial method. So we have x, and then the square root of 900 is 30. So we're going to have x minus 30 squared, but we still have to divide by the number we slid. And so that is going to give us a fraction we can reduce, which is x minus 5 over 2 squared, and we're going to slide back, which gives us 2x minus 5 squared. And there we go. So our steps currently when factoring, we're going to factor out that GCF whenever possible. That's always step number 1. And then we have a new step number 2, because we're going to ask ourselves, is this a special case? Because of course, if it's a special case, then we have some shortcuts. So if it's a difference of squares, we have a pattern for that. And if it is a perfect square trinomial, we also have a pattern for that. And of course, if you don't like the pattern, you can always factor it like normal and still get the answer. You just remember that you need to put those identical factors together as a squared term. Then, if it is not a special case, you will need to look at it and see if it is a trinomial with a leading coefficient of 1 and factor that accordingly. And if that is not the case, then is it a trinomial with a leading coefficient that is not 1? And if it is that, then you will need to slide and divide.